So, good afternoon. I'm Alan Ewing, the Executive Director of CBRS Alliance. Wish to welcome you to the reboot of the CBRS Alliance's Lunch and Learn program. It's been a little while since we've done Lunch and Learn. I think our last one was in January before events of the day have put us off of doing these in person. And we've been working on doing one virtually for a little while. Fortunately, our friends at Communication Technology Services and RanPlan Wireless have been working with us during this time to be a little bit of our guinea pigs, but also to be the champions of helping us get this program restarted. A couple of things, a bit of housekeeping before we get started today. If you do have questions, we welcome those. What you will see on your control panel for GoToWebinar is you will see a question panel. Feel free to put questions there, and I'll be curating those for our presenters. Secondly, we are technically in Lunch and Learn. We had a vendor that we were working with to supply the delivery of lunches, and that vendor kind of flaked out on us, frankly, a little bit. And so what we're doing this time is those that attend that met the criteria that we set forward in the invitation, you'll be receiving an email after the webinar that includes information about a gift card so that you'll be able to order lunch through one of, I believe it's Grubhub, if I'm not mistaken. And so there'll be some help there. So other than that, basically, I want to tell you a little bit about the Alliance before I introduce our presenters. So Josh, you go to the next slide. So the CBRS Alliance, we support the ecosystem through specification development, certification program, advocacy, and community building. So what you see here is we build on the 3GPP specs, we write and we operate cert programs to verify interoperability. Our advocacy ties us to the FCC, the Department of Defense, etc. And our community building is really about bringing folks like you together. So that's very exciting as well. So next slide. So some of the Alliance initiatives that are ongoing right now, it's a partial list at best because there is a lot of things happening right now. But 5GNR specification development, coax specification enhancement, our certification program is growing in scope. We're working on OnGo for Dummies, which is the For Dummies book that you see on all other topics. There'll soon be an OnGo for Dummies available for download as well. There's the OnGo Awards, deployment guides. Tomorrow there is a webinar on our first deployment guide, our private LTE deployment guide. And so if you're interested in that, information is on the cbrsalliance.org website. Then research report projects. We're doing some research work that we're providing to our members. Our monthly webinars, our trade show presence, our public website is being updated, and of course our Lunch and Learn program. But this is just a part of the list of the things that we're working to keep folks connected. Next slide, Joe. So of the ecosystem that we'll be talking about today, already there are 43 OnGo certified CBSDs. These are the base stations, the eNode Bs, the indoor or outdoor deployment infrastructure. We'll probably have around 50 by the end of the year. And then already 121 band 48 end user devices that have been authorized by the FCC as well. And this number is growing even faster, so probably in the neighborhood of 145, maybe even a little bit more by the end of the year. End user devices include all types of form factors, phones, routers, tablets, modules, hotspots, laptops, etc. And the things you'll be hearing about today from our presenters really talks about that private LTE deployment and how that, these kinds of things form the foundation for those deployments. Next slide. A little bit about OnGo. So OnGo is the brand name under which we operate. So OnGo is LTE and 5GNR in the CBRS band. So just like Wi-Fi is a brand name for 802.11-based technologies in the unlicensed bands, OnGo is the brand name of LTE 5GNR in the CBRS band. So this is something that we'll be featuring even more prominently in the rest of 2020 and into 2021. So when you hear OnGo, think spectrum sharing. Think about how this all works, and really it's all about, you know, this opportunity that we're creating for innovation. Next slide. So our future member meetings, we do member meetings different times during the year. All of our meetings right now have been virtual. We're hoping to get back to face-to-face next year, but let's see how that plays out. But our next members meeting will be October 5th through 7th, and there is for our members, you can register if you haven't already. If you're not a member, there is, and you'd like to at least sit in on a few of the sessions, you're welcome to contact me or our admin team, and we'll be happy to discuss that with you. And then next slide. What's ahead for 2021? So the PAL auction is completed. We're heading, you know, this full commercialization is now, has the PAL operational in it. Publication of our release 4 specs, development of our release 5 specs, certification program is going to be growing. And then we're, like I mentioned earlier, all these different member engagement resources will continue to expand and build on this as well. And really getting everybody, you know, the auction generated $4.5 billion in revenue for the gross revenue. What we're seeing is now it's time to amplify the message and really live up to the promise of what we've all signed up for. Next slide. So very happy to introduce our speakers today. We'll start with Dr. Bu, who is Vice President of Mobile Strategy and from Communications Technology Services. And then Dr. Bu will transition over to Dr. Zhang, who will take us on from there. But Dr. Bu, could you join us here on the video? And I'll turn it over to you, sir. Thank you.
Thank you, Alan. Thank you for this opportunity to share some of the lessons we learned from CBRS, and we want to share some of the experience we have in designing CBRS-based networks, some of the key factors we want you to consider when you deploy these kind of networks. Next slide, please. So we'd like to do a little introduction of CTS, and then we'll follow with some high-level introduction of CBRS, and we'll get into the key factors of the CBRS-based networks. Communication Technology Services, CTS, is actually a national system integrator. We are based out of Marlborough, Massachusetts. We've actually been around for 30 years. Actually, this month, September, is actually our 30-year anniversary. We have done over 9,000 projects over the course of 30 years, and we try to become the premier national integrator for all your mobility and wireless needs. Next slide, please. So we have 20 offices across the nation. As you can see, that we have resources from coast to coast. Our goal is to provide our local PM and managing services in all the major NFL cities, and then we supplement it with our resources with our contractors, our partners, to provide services nationwide to all the continental 48 states. Next slide, please. Next slide. This one is showing the map of all the projects we've done over the years. As you can see, we pretty much have footprint all over the United States, and we have experience and projects experienced all over most of these states, except for some of the states in the middle of the country. Next slide, please. Our services is focused, as I mentioned earlier, we become trying to become the premier system integrator. So our focus is mostly on the private network side, cellular DAS, and small cell solutions. So we're trying to provide end-to-end solutions for all of the customers and our partners here. That includes public safety, wireless LAN, fiber-based LAN, consulting services, general contracting services, monitoring and maintenance services, structured cablings. So our mission is to become your trusted partner for all your infrastructure needs really helping you guys through all the changing technology landscapes. Next slide, please. All right. So I want to go through some very high level basics of CBRS. So CBRS, as you may have known, it stands for the Citizen Broadband Radio Services. Is really a third way of providing network services in the shared spectrum format, other than the licensed spectrum, which is usually used by the network operators or unlicensed Wi-Fi operators. So CBRS provide a different way that encourage the enterprise to deploy the private networks and also support and development, commercialization, adoption of private network for enterprise as well. So, next slide, please. So in order to implement the shared spectrum, please go back slide. In order to implement the shared spectrum, so the FCC decided to adopt this three-tier mechanism. Tier 1 is reserved for the incumbent. Tier 2 is actually the priority access license that's just been auctioned in July and finished in August last month. And then Tier 3 is the general authorized access. So most of the enterprise users will be focusing on the Tier 2 or Tier 3. And what this allows is to give the licensed users up to 7 channels per county, and the GAA users up to at least 8 channels for your general enterprise use, so that you don't have to pay for the license, but you do have to register with the company called, or the management company called Spectrum Access Systems, SaaS companies. So you do have to register your system through SaaS, but you don't have to pay for the license fees when you're using GAA. So next slide, please. So I want to provide you a summary of what happened during the PAL license auction. So this license has, the auction has happened since July 23rd and finished on the 25th of August, and 3,300 or so county-based licenses have been awarded, and a total of 22,000 licenses has been bid out, and it generated $4.58 billion of revenue to the FCC, and a total of 271 bidders actually participated, and we're expecting by January 2022, you're expecting the license being issued, and the license winner is going to start building out the networks. All of the top 20 license bidders, you will see most of them are carriers, cable operators, utility companies, and a lot of large enterprises all participate in this license auction. So this is very encouraging, exciting news for the industry. So we'll see a lot of the deployment and development in this area next year and the year beyond. Next slide, please. So in a CBRS-based network, there are 4 major components. And number 1 is really the license spectrum, as I mentioned earlier. So you have to decide whether you're going to go with a GAA license or PAL license. And then you also have to find out what you're going to do with spectrum, the SaaS vendors, which one you're going to use. The second is the second component of the CBRS network is the EPC, Evolved Packet Core. So this is the brain of the network, really determine how you function, how the network is going to be put together, and how to process the calls, and what kind of functionality you're going to have on your network. Third one is the CBRS devices, or CBSD, which is really the ENOB, the radios that broadcast our signal throughout the facility, throughout the used areas. Number 4 is the end user devices, applications. Those are the phones, the devices, gateway routers, those applications that can be used on the private network, can utilize the CBRS signal, and then be able to provide the application, the use case that you're looking for in your particular facility or buildings, all that. Next slide, please. Next few slides, I'm going to go through some of the key factors when you look at each component of the CBRS network. And first, like mentioned earlier, is the license and spectrum planning. So when you started to design your CBRS network, you have to figure out what kind of device is going to use and what kind of application will be riding on those devices, and then the bandwidth requirement of those devices. For example, as you can see on this sample here, video cameras usually have a different, requirements as far as uplink, downlink throughput versus the IoT devices versus some of the signage or VoLTE devices. So that's something you have to determine at the first thing when you're trying to do a frequency planning. After that, you have to decide how many sectors, how many channels you need to support that throughput, that bandwidth. And then once you've done that, you need to reach out SaaS providers or SaaS partner you chose to decide, is there available spectrum for you in the area you're in to go with either GAA, or do you have to go to a PAL license owner to sublease the license, or determine what you can do to have enough spectrum to support your operation. So those are the three key things that you have to consider when you do your spectrum planning. And once you've done that, you can move on to the next component, which is EPC. Next slide, please. So when you consider your EPC selection, one major item you have to decide is whether you want to go with a cloud-based or you want to go with a edge EPC, which is on-premise. So when you go with cloud-based EPC, it's much easier to deploy because everything is residing in the cloud. You only need to worry about the connectivity between the cloud services to your local devices. So it's usually a lower cost deployment, easier to manage, very scalable, and also easy to upgrade and maintain. On the other hand, if you have latency requirements, you're looking for very low latency, high throughput, high security deployment, the recommendation is to go with a on-premise edge EPC, where you have the EPC on the premise, all the processing, the data collection is already processed on site, and then you will reduce that latency, improve your throughput, and also provide the maximum security you're looking for as far as your data goes. So obviously that comes with a higher cost because you have additional equipment on site, and then it requires specialized people or maintenance crew to manage, operate those. So those are two versions of EPCs really are the main factor you have to decide when you're looking at selecting a proper EPC for your private LTE or CBRS deployments. Next segment, I'm going to go through some of the deployment scenarios for your radios. Next slide, please. So from our experience, we look at the deployment scenarios of radios. We found there are like typically 4 different types of deployment. First 2 are small cell based. One is standalone or hybrid model. The next 2 are similar to traditional DAS deployment with either standalone CBRS or CBRS hybrid. So I'm going to go through each one of them in detail in the next few slides. Next slide, please. In a small cell-based standalone CBRS, this is very much similar to a Wi-Fi deployment. The small cell deployed very much like the access point of Wi-Fi, and the only difference that is broadcasting in a CBRS 3.5 gigahertz, and all the controlling the SAS EPC are connected to the baseband unit and the radio controller at the head end. And then usually the connection is including fiber or category cable, and very straightforward deployment. And usually this is done when you have some kind of LAN infrastructure or fiber infrastructure in place. This is very easy to deploy in a in building environment or some of the outdoor deployment as well. Next slide, please. So this is a small cell based hybrid model where, as you can see, you could have a hybrid CBRS and Wi-Fi or cellular radios in one bundle. So this utilizes one infrastructure that provides two different networks on one infrastructure. So the only difference this one versus the one previous is that you can support another different service. Could it be cellular service? Could it be a Wi-Fi services? And using one combined infrastructure, and then the signal from the Wi-Fi or from the cellular is injected into the baseband, so that you utilize only one LAN infrastructure. So this is typical when you have existing Wi-Fi network, you want to add a CBRS layer to it. It becomes very cost-effective to deploy a additional CBRS private LTE layer. That way you can enjoy the benefit of both Wi-Fi and the CBRS. Next slide, please. A third way of deploying the radios, CBRS radios, is using a fiber coax-based infrastructure, very much similar to what it would deploy in a traditional DAS perspective. So you would have the baseband unit at the head end, and then run the fiber to the remote locations. From there, you connect everything through a passive infrastructure, which includes the KOS cables, splitters, antennas, or so. So the antennas are usually supporting the 3.5 gigahertz, or could be broadband antennas that covers anywhere from 400 megahertz to the 6 gigahertz range. This is very typical in a high-rise buildings or some of the manufacturing plants where you need to have you don't have as much capacity requirements, where you can have one radio cover quite a bit, large areas, and then you need to have the RF signal split into multiple antennas. Very much like how most of the DAS is deployed nowadays. Next slide, please. The last model of the CBRS deployment, radio deployment, is the fiber coax-based hybrid model. In this particular case, is that a different signal or different input is injected head end. Usually the head end has CPRI capability or mocking capabilities, that where you can have a different source signal inject into the network. So the idea is to utilize the same fiber coax DAS, but you can combine the CBRS deployment with another services, usually the licensed cellular services, into one complete network. This is traditionally how DAS has been done, very much similar, and could be used for buildings or facilities that already have a existing DAS infrastructure, try to inject or add another CBRS layer to it. So we're probably going to see a lot of these deployments once the power license started to deploy their network. They're looking at overlay of existing networks with the CBRS layer. All right. So the next slide, please. Last component of the CBRS network is the applications. So there are new devices, use cases, applications being developed on a daily basis. We categorize this, all these use cases, all these applications into three major categories. Number one is really the replacement augmentation of applications running on Wi-Fi. So this is the way to utilize CBRS and private LTE to get a better range, better reliability, security, and sometimes also supplement the public Wi-Fi for private use. We see a lot of these applications or use cases being developed. Second is the use case to utilize CBRS as a base network for IoT applications. So the way to do that is to aggregate, converge various IoT technology into CBRS network. So that includes some of the narrowband IoT, LTM, LoRaWAN, Bluetooth, low energy, Zigbee, to support those different IoT technology, and using gateways, using routers, and then bring them all onto one private LTE network. Third application of private LTE CBRS is what we call neutral host. I think that standard is still being developed by the CBRS Alliance, but we do see quite a bit of potential in that use case. So it's really to use the CBRS as a cellular standalone cellular network or coexist with a DAS or small cell network to provide cellular voice and data. So as you can see, they're still being developed right now. But we see huge potential for that particular application for CBRS private LTE network. Next slide, please. So here are some of the CBRS private LTE applications. As you can see, when CBRS is used in cases where wired area LAN is required, Wi-Fi may not be sufficient, or they have different application needs to be running on one single layer, one single network, and sometimes the public network is not an option. For example, in warehousing situation, amusement parks, smart cities, sometimes hospitals. As you can see, one of the common applications really the IP cameras, security cameras, some other applications including the vehicles or kiosks, digital signage, some of the other applications related to recent COVID-19, touchless scan, touchless access, or human-based monitoring. Those use cases are being developed due to COVID-19, and also some of the e-learning cases are being applications are being developed on a daily basis to really take advantage of CBRS private LTE networks. So, in order to design a proper CBRS networks, we have used IB-Wave and the RanPlan as well. So, next section, I think Dr. Zhang is going to present how the RanPlan can be used to deploy or design a good CBRS network. And I'm finishing my part of the presentation. I'm going to hand it over to Dr. Zhang to explain how RanPlan can be used to do the planning for CBRS networks. Thank you.
Thank you. Thank you.
Thanks, Dr. Vu. Excellent. So, Dr. Zhang, could you turn on your video, please, sir? And we'll hand it over to you. Very good. I will turn the mic over to you, sir.
Thank you, Alan. Thank you, Dr. Vu. So the first slide. Yeah. So in the next 25 minutes, in the next 25 minutes also. Yeah, the cover page, please, Josh. Thank you. The cover page. Okay. Yeah. So yes. So in the next 25 minutes also, I'm going to talking about deploying CBRS-based private LTE networks. So thank you, Alan, introduction. For those who don't know me, which is not surprised because I normally operate in academia. So I'm founder of RanPlan Wireless, and also I have held the chair in wireless systems at the University of Sheffield for the last 10 years. So next slide, please. So I will start by giving an introduction to RanPlan, and then I will focus on CBRS-based private LTE deployment. If you are familiar with the white paper, understanding CBRS-based private LTE networks, this is section 6 in the white paper. So I will talk about 3 scenarios. The first one is fixed wireless access. The second one is in building hotel deployment, and the last one is stadium. Next slide, please. So now come to RanPlan introduction. So yes, so RanPlan offers RanPlan Professional, which is the fastest indoor network planning tool in terms of, for example, saving times for IFR designers. Also in terms of the computer running times. So it is also the world's first combined indoor and outdoor network planning tools. So it supports multiple radio access technologies, including CBRS-based LTE networks. So where we are headquartered in Stockholm, Sweden. we have also 3 subsidiaries. RanPlan UK is our main R&D team, which is just outside Cambridge, UK. We also have RanPlan Americas. So I believe this CBRS-based LTE network planning will be handled by our US team, which is based in Plano, Texas. We also have a 3rd subsidiary, RanPlan China, so it's in China. We are a public company listed on Nasdaq First North, which is in Sweden, and we have a global customer basis. We have won more than 20, I would say, awards and grants. So, for example, this one is this year's Small Cell Awards in this software and service categories. Last year at Interop Japan, we won this the Best of Show Award for our world-leading 5G new radio planning capabilities. This year also, we are recognized by the European Commission as a key innovator in radio network planning and optimization for ultra-dense, small cell, and heterogeneous networks. So next slide, please. We have a comprehensive suite of software solutions. I have already touched on RanPlan Professionals. We also have a RanPlan tablet, which is on-site survey and also automatic network design tool. The 3rd tool is RanPlan Collaboration Hub. It is a cloud-based project management and workflow tool where you have many projects, or you have a different member of a team to manage the same project. It will significantly enhance the productivities. Next slide, please. Now we come to the second part, is a CBRS private LTE deployment. So as I said, it's I'm going to, sorry, yes. As I said, I'm going to talk about fixed wireless access. Yes, this slide. In building and stadium.
Sorry, there appears to be animation in the slide, so it's moving forward without my control. So apologize for that.
Okay, sorry. Josh, next slide, please. Next slide, please. Yes. Okay. So this is now come to fixed wireless access planning by RanPlan Professional. So if you look at the bottom right, we divide this planning into 5 stages. So the first stage is the outdoor scenario modeling, and also the second stage is called high definition building modeling, which you can see on the figure bottom left. So in this fixed wireless network planning, we need to answer these questions like where should outdoor CBRS LTE base stations be located, and how should the base stations be configured? So, and where should the indoor CPEs be installed? So, with RanPlan Professionals joint outdoor and indoor modeling capabilities, all these questions can be answered, and also you can eliminate a significant amount of manual measurement and testing work, because both the indoor and the outdoors can be modeled, and also we have a very accurate radio propagation predictions. Next slide, please. Yes, thank you. So this slide actually shows you the third step in this fixed wireless access planning process. So it is microcell coverage and capacity prediction calculations. So, for example, what we see from these figures, for example, on the bottom left. So we can see the this visualize these KPIs like, for example, SS, RSIPs, SINR can be visualized in these different floors, and also in different at each floors we can see at a different height. Therefore, we can identify the best locations for CPE installations. If you there's a video, animation video, but if you press the next page, I think it will yeah, excellent. So if you look at anyway, let's move to this page anyway. So on this page is it shows the last two steps for fixed wireless access network planning. So step 4 and step 5. This means sorry, is CPE and RBS design, and also the fifth step is CPE system coverage and capacity calculations. So what demonstrated here is this we can also install a standalone CPE for example, with the built-in antennas, but also we can also redistribute the signals using indoor distributed antenna system. So all these both solutions can be evaluated using our tool. So, next slide, please. The next is yes, is this for in building CBRS private LTE network for hotel. We believe like hotel venues and enterprise such as smart trees, these scenarios are very important for CBRS-based private LTE network deployment. So what can show, what we can see here is so the tool can first it build 3D building models. Second, it can then design DAS networks in a very automatic manner. So thirdly, it can produce all these performance evaluations like SS, RSIP, RSI, RSIP, many of these parameters, and throughput. We can run these simulations. And also, fourthly, it can produce automatically generate many of these reports. For example, let's move to the next slide. You can see a couple of reports. This equipment budget, yes, this equipment budget report. So this is automatically generated, like the bills of the materials. We can calculate the equipment cost and also the construction cost. There are in total 13 reports. For example, like antenna ERIP report, keyboard routing report, equipment list report, and etc. There is also a comprehensive report which generate project report. So this can significantly save time when you design CBRS-based LTE networks. Next slide, please. So the last scenario The last scenario is a CBRS-based LTE small cell deployment in a stadium. You can see these complex structures like a stadium can be modeled very accurately and also very quickly with RanPlan professionals. And these are like performance metrics like RSIPs on this bottom left, and also this PDSCH throughput, downlink throughput on the top right. So all these are, there are 26 KPIs in total can be evaluated by our tools. This gives you, for example, the confidence of the performance of your network. Next slide, please. Yes. So this means, for example, our tools can give complete solutions. This means first, RanPlan professionals. It gives it can model both the outdoor and the indoors. Let's say 2 centimeters. For example, it can model this 40 square kilometers for campus or for city center in an urban area. So to study both the outdoor and the indoor LTE network deployment. So that is RanPlan professional. Secondly, we have a suite of software. So apart from RanPlan professional, we also have this RanPlan tablet, which allow you to do, for example, some of the on-site service, annotations, and also video recordings, and also do some of the quick design on site. So, and for larger project, we have this RanPlan collaboration hub to provide efficient project management and also workflow management. So this means it's a complete solution for this radio network planning and optimization for CBRS-based LTE network deployment. So thirdly, the complete solution also means we are quite open. We would like to work ecosystem players, for example, mobile network operators, venue owners, and also system integrators, and also network vendors, even the SaaS server providers. Because I see this CBRS is a great opportunity. Only if all the players in the ecosystem can work together, can make it a success. And we are very willing to work with you. Just as an academic, I would like to turn what we developed in academic research into commercial tools that really contribute to our community. So therefore, the complete solutions mainly means all the players work together to achieve the potential of CBRS network. What we can play is for this CBRS-based network deployment to plan both the outdoor and the indoor, and also the management. Next slide, please. This is actually a video. Yes, I'm glad it works. So you can see this like we can model this 3D necessary MIMOs. You can see the difference between the service beam and also the broadcast beam. So you can see the two actually is more or less a model outdoor environment. With you see this is with actually meditation. I see. You can see from the outdoor to indoor coverage. It's outdoors. It's yes. So you can see it has a great animation capability. It looks like a CT scanner. So it tells you, for example, where the weak signals are and the circles. This is particularly useful for example, for fixed wireless access, where you decide, when you identify the candidate CPE locations. So that's it. Next slide, please. So these are some of the advantage of using RanPlan. Yes, we have worked with a number of mobile operators to benchmark the savings for KPAX. So roughly is about 30% of our KPAX savings. We are writing entry with leading operators to one of these key studies. Of course, for CBRS-based private LTE networks, this means for venue owners, enterprise, and many other verticals. So, and also in recent comparisons from one of the system integrators, it's not a CDS, RanPlan delivers over 100% productivity gain over the main competitors for in-building wireless network design. And also, we are the world's first and also the most matured. Probably at the moment, you can do the, I believe at the moment, if you do the both the outdoor and the indoor event tool, this is the only RanPlan tools you can work. I don't think others, you have to using multiple tools, or there's some others not mature enough to be used. And from some of the benchmark, it is far faster prediction run times and also more accurate. So because we have been, for example, doing world-leading research in reading propagations for nearly 2 decades. So at the University of Sheffield, under my chair, I lead a team of 30 researchers at the PhD levels or above. So this means our research is we're doing world-leading research. Some of the most cited publications actually come from my group in small cell, head net, and the circuits. So we also have this advanced building structure modeling. So currently is also the best class, best in class already, but also now we are going to take it to another level using some of the deep learning technologies. Because we develop many of these technologies. We are also independent. This means that there's no hardware bias. This means that crucial for vendor selections to move on with the venue owners and enterprise. As I already mentioned, we have this research leadership. This means feature proof. Yeah. Next slide, please. So I thank you, Alan and Josh from, in particular, from CBRS Alliance, and also our partners, CDS, in particular, Dr. Boo, Rahul, and Kate, for your cooperation. From the RanPlan side, I would like to thank Jason and Zhang and Cap, who helped me either organizing this event or provide some slides for the presentation. So also thank you for listening. Next slide, you see our contact in the US. Josh, next slide, please. Oops. Okay.
Yeah, we'll go
back. Thank you. Okay, thank you. Thank you very much.
Dr. Zhang, thank you very much. And we always learn about animations on our slides this way, unfortunately. But we'll make sure that folks can access some of this information. Dr. Boo, thank you for joining us back. We have some questions, and I've come up with a couple of questions too. So, but I'm going to start off with one, hopefully a fairly simple one, Dr. Boo. Do you provide a cloud-based EPC that CTS is hosting? Is that something that you guys host? Oh, you're muted. Let's see.
Yeah, sorry, sorry, I was muted. Yes, not yet. So we are actually working at our office to put a server in, try to beef up the network so that we can host EPC. Yes. We're working on it, but not yet available.
Got it. And I'm just capturing that for posterity. So, Mirga, I thought we'd start off with an easy one. That would be the first one. So, oh, sorry. Let me delete my answer. It looks like Josh and I were working together there. So thanks, Josh. I'll let you do the answers, Josh, and you can fix them for me. So one of the questions that's come up, and let me start, Dr. Zhang, for you. What is one of the more surprising things that you've learned in doing network planning with your tool? Is there something that is from a research or from a practical perspective that has really surprised you when you've done a modeling exercise on a building or other, location that you could share with us?
Yes. To be honest, one of the surprise is what we found. Of course, so far until now, given a building, we are going to design or optimize networks to suit the building. It's a surprise to us is for example, sometimes actually you should take a building, modify building to improve the performance of the network. Sometimes it's actually much more efficient. I believe this is going to be a direction in the future. So in the future, network optimization involves also modify the buildings. Actually, for the 6D study, we have already seen this trend. For example, there is a new technology called intelligent reflecting surface. This means that you are going to put in some of this intelligent surface in some certain part of the buildings. So, for example, to retransmit the signals from base stations more intelligently. So that's to be honest, we pioneered this. My team developed this groundbreaking work in this area. We therefore we found this actually about a decade ago. So therefore, we developed a framework basically to model the wireless performance of a building. We have a hypothesis that is, for example, the wireless performance is not decided by wireless networks. It's actually the upper bound decided by the building structures and the material properties. This probably, I don't know, it probably is a little bit too deep, but yeah, that's a surprise.
Got it. No, very interesting. Thank you, Dr. Dr. Bu, from the perspective of network planning, what has been your view of the tool and how has it influenced the work that CTS has done? Perhaps maybe a way of looking at this.
Yes, I think the main benefit when we look at this tool is the capability of integrating indoor-outdoor planning into one tool. So we have a lot of deployment or scenarios where customer has a building, then you have the surrounding areas, or in a smart city deployment, you have a 2 square mile area that you have to do prediction or planning for. Traditional tools, you either do it from a macro level or you do it building by building. It's this tool, RanPlan, provides you a realistic view of inside out and outside in, where you can predict the antennas transmitting from outside into the building, also predicting the signal from bleeding from the indoor antenna to the outside street. That overall realistic view is really helping you to determine, okay, where is the broader line, where is the cutoff, how do you plan your sectorized boundaries, how do you do planning your capacity, movement, and channelization, those kind of things. I think is a very unique and very useful feature, especially when you do CBRs where private LTE, if you want to deploy a network slicing where different performance matrix deployed in different areas of the facility, for example, high density videos only in this areas versus outdoor cameras is a different, or access control has a lower, IoT environment. So that kind of interference planning or a prediction would be very handy to determine the capacity and the network planning perspective. So
interesting. Thank you. No, this is all fascinating. The ability to do this kind of planning is really remarkable. And the modeling tools are fascinating. It's always nice to be able to visualize something that isn't intuitive like that in such a nice way. A question from our audience. How does neutral host play into this picture? There's obviously private LTE, but that next step of deploying neutral host, is there any impact from the network planning perspective? And I'll open this to both you gentlemen. I don't know who wants to start first. So.
Well, I'll start first since Dr. Zhang's first question. So I think it definitely is a different challenge for network planners and system integrators, because traditionally you look at the capacity from the point of view of the carriers, looking at their subscribers, and they look at their coverage or capacity matrix. But in this case, when you're looking at private LTE, you need to take an overall approach to say how I'm going to use a private LTE to provide equivalent capacity to all the users out there within the facility, as well as customer or guests might come visit the building. So you look at all three carriers, they have, each one has maybe 30 or 40 megahertz. Now you look at CBRS, you have to look at how much spectrum I have, how many channels I have available to provide equivalent capacity of a neutral host or traditional DAS in a CBRS only neutral fashion, right? So you need one layer to replace multiple layers of traditional DAS. So you have to look at that from that perspective, and then look at how you distribute the capacity, distributed channels throughout the facility, and then you determine whether GAA will be sufficient, or do I need to go beyond the GAA to maybe sublease some power license. And then you also have to look at some of the throughput requirements. Traditionally, that is a little bit beyond what you normally do on the traditional DAS deployment. Now you look at the applications, or certain deployment requires a guaranteed throughput. For example, if you want to use CBRS as a wireless internet access, so you have to guarantee certain throughput. Now you have to look at that throughput, say 100 megabits up, download, 50 megabits upload. That kind of throughput, what kind of capacity planning or spectrum you need to provide a guarantee to all the users out there. So it's a little bit different challenge when you deploy a neutral host, CBRS only neutral host model. Then another main factor is how you handle the roaming in and roaming out, right? So that's still being a challenge right now. Technically, you can deploy a network that can meet the coverage capacity requirements, and then when you deploy the network, actual implementation of the network, you're going to have to resolve the roaming in and out from the private to the public network, from public network into the private network. That's still something that I believe a lot of companies still trying to figure out how that can work out.
Got it. Dr. Zhang, anything to augment?
Yeah, I think at least we have more spectrum. This means we have more capabilities. This means either we can serve the neutral host can serve more users, or using carrier aggregations to provide higher bandwidth to particular users. So this is very helpful. The other thing is, I think this neutral host in the future, I believe this like FCCs, like Ofcom in the UK's, they are going to release more spectrums for example, for shared spectrums, or therefore this if we look at this spectral collaborations, this neutral host is ideally positioned to handle these spectrums. Otherwise, this spectral collaboration need, for example, very advanced artificial intelligence algorithms and the super computers to calculate which users should use which separators at which place. I believe this neutral host, in particular for CBRS mainly targeted, let's say, the buildings. This is perfectly suited. So naturally collaborate.
Understood. Thank you. Yeah, the neutral host discussion is always fascinating as it becomes real and really the next stage in the promise of what we're all trying to deliver. Dr. Zhang, question came in: is the RanPlan network planning tool based on a cloud? Is it cloud-based on a cloud-based platform?
Good question. We have these three tools. One is a RanPlan Professional. The other is RanPlan Tablet, and the last is RanPlan Collaboration Hub. This RanPlan Collaboration Hub is cloud-based. Yes.
Very good.
And also, for your information, we are also working with ambitious operators to move our RanPlan Professionals onto the cloud as well.
Understood. Understood. Very good. Thank you. Dr. Boo, I was kind of fascinated when we were talking about the different use case models. And, you mentioned the hybrid DAS model in particular. Where can you give us a few examples to get our head around that particular use case, where that would be practical or where it's being seen out in the world?
So, as I mentioned in the presentation, I think that is very useful, especially when the PAL license users or owners are going to deploy their CBRS layers, because for some of the legacy DAS buildings with DAS, you can add a CBRS layer onto the existing DAS infrastructure without adding any cabling or fiber to that. So that hybrid model, several OEMs are developing that hybrid model where instead of another layer, a brand new system, so developing separate CBRS module that can be added to existing remote in an add-on fashion, or like a daisy chain, a tethered fashion, where the CBRS signal is going to be broadcast or injecting the system through a separate remote, but you don't have to necessarily layer another antennas or cabling for that. So we've seen several vendors, OEM vendors, actually developing that product as an add-on to the existing DAS modules. So.
Very good. No, thank you. Yeah, it's one of those getting my head around the whole concept, and even though I do deal with this on a regular basis, of course, still visualizing or conceptualizing it so that I understand better is always good. Any other questions from the audience? So I've seen a few. We've had a few good ones come in. Many of them have been regarding, contacting your companies individually to discuss business opportunities. That information will be made available, of course, in the slides. So don't worry, anyone here in the audience, you'll be able to contact these gentlemen and their representatives. I'm sure they would love to talk to you about potential opportunities. So don't worry about that. I know that in my discussions with Jason in particular from RanPlan, there will be some emails coming out to our member company participants that participated in the event today regarding some opportunities to exercise the software a little bit. And so watch for emails from RanPlan and from CTS regarding how you can do a little bit of demoing of the tool and a little more hands-on practical experiences there. So we're very, very excited with that offer from you, from your companies, and appreciate it very much to help build this community. As one of my core activities is to really build CBRS to be everything it can be for all of us. I haven't seen any more questions come in. I know just one other note, we will be sending out the lunch cards that we had ready. So you'll have a lunch after the fact. You won't have lunch during the fact. My apologies for that, but this is a new experience for all of us, how to work in this virtual world. And you know, it's a learning thing that we're all going through. So we appreciate your patience. We appreciate your attendance and attention today. If there's no other questions, Dr. Bu, Dr. Zhang, any other final points you'd like to make sure we make today before we end our session?
My main point is really grateful for Alan and George for organizing this webinars, and also Dr. Bu, Rahul, and Katie, our from CTS, to work with us for this meetings, and also water papers, and our team at RanPlan, and also the audience, of course. Thank you very much. Yeah, so it's something because my screen is very small. I hardly read it. So there's some point. I was not very smooth. Apologize.
Yeah, this has been a challenge for us all. Dr. Bu, any?
I think this is a great experience. I was just wish that we could have something chow on, right? So, but instead we were just, you know, only can, you know, meet everyone virtually, and hopefully everyone enjoyed the lunch that provided here. And you know, I really appreciate Dr. Zhang and Alan and CBRS Alliance to give us this opportunity to share what we learned, and I wish we can participate in more of this event. I think this is, in a real world, I think this is actually a really good event to bring everybody together, but hopefully virtual environment can do the same thing.
Yeah, and I really appreciate you guys being, and CTS, RanPlan, I appreciate all of you being so willing to engage in this experiment and work with us in such a positive way. It is very much appreciated from the Alliance's side as well. You know, one of these days we'll be able to get together again and enjoy a meal together and discuss these things, and that, of course, is always a much more enjoyable way to have these discussions. But with that, I would like to say thank you again. Thanks to our audience, and we'll go ahead and wrap up today. Please stay well, stay healthy, stay safe, and we're looking forward to all being together again in one room all together at some point in the future. So take care, enjoy the rest of your day, and thank you. Bye now.
Thank you.
Thank you. Bye.
Bye.
Take care.
Bye.
Bye.
Bye.